Welcome. This is Algebra 1B Part 1, Unit 5, Lesson 9. Solving quadratic equations using patterns. So far we've been solving quadratic equations by factoring, by regrouping and factoring out a common factor and several other techniques like this. This is just pattern recognition. So the old methods can still work on all of these, and I'll show you those as well as the patterns. I'm not going to get into depth about the patterns because there's 3 different cases and they are fairly involved, so I'm going to leave that to the lesson. So I'm not going to say they're not important, but you can solve all these problems using the techniques that you've already learned so far. So let's take our first example. X squared plus 15x equals negative 54. We have a problem in that this is not what we call in standard form. Standard form means everything is on one side of the equation. Ax squared plus bx plus c equals 0. And then 0 is on one side all by itself. So we need to get the negative 54 over to the other side. So we're going to add 54 to both sides. Now there's no constant to add it to, so it simply gets tacked on the end. And this now looks like x squared plus 15x plus 54 equals 0. Okay. Now you may recall in the previous lessons we'd now be looking for factors of 54 that add to make 15. And then we break the 15x into those two factors. But we can kind of skip that step a little bit by doing this. So think of things that multiply to make 54. I always start with 1 to make sure I don't miss any. 1 times 54. 2 times, you can use a calculator to divide 54 by 2. You get 25 and 2 or 27. Let's see, 3 times 54 divided by 3 goes once. 24 goes 8, so 3 times 18. 4 doesn't go, right? 4 doesn't go. 5 doesn't go. 6 does go. 6 times 7, 6 times 8 is 48. 6 times 9 is 54. And then 7 doesn't go, and that's about it. And we're looking for factors that add to make 15. Well, 6 and 9 add to make 15. Now, you may recall before I would then write 6x plus 9x plus 54 plus x squared, and I'd factor out a greatest common factor, x, from the first two, factor out a 9 from the second two factors, and so forth, and do all of that. We can skip all of that as we recognize that we can simply break it into 2 binomials with 6 and 9. So this is x plus 6, x plus 9 equals 0. Just check. 6 times 9 is 54. 6 plus 9 is 15. So that works. Right? And then use the zero product property, which says if 2 things multiply to be 0, one of them must be 0. Either x plus 6 equals 0 or x plus 9 equals 0. And then subtract 6 from both sides of the first equation. And subtract 9 from both sides of the second equation. Okay, so x equals negative 6 or x equals negative 9. And solution set, negative 6, negative 9. Okay, one extra step. We could plug them back into the original equation and see if we get equality. That is, if negative 6 squared plus 15 times negative 6 equals negative 54, and it does, and negative 9 as well. But I won't take the time to do that right now. Okay, so that's example 1. That you can skip a few of the steps in between and simply look for factors of 54 that add to make 15 and put x plus or minus. Now, if this were a minus, then we'd put minus on both of them. Okay. All right, so next, x squared minus 14x plus 49. Now, they're going to tell you that this is a pattern, but I do want to show you that you can still use the old methods to solve this, right? Think of factors of 49. They are 1 times 49 and 7 times 7. That's about it. We need factors of 49 that add to make 14, and you'll note that 7 plus 7 makes 14. And so I could simply write x minus 7, x minus 7. And you notice the two terms, they match, and so we can actually shorten this to x minus 7 quantity squared. And the hallmark to recognize this is something called a perfect square, where this is a perfect square. The hallmark to recognizing this is this. 14 can be written as 7 plus 7, and 49 is 7 times 7. So we recognize that the middle term is the sum of the two terms and the two factors, and for the last term is the product of two factors. And when that happens, you have what's called a perfect square. That said, if we recognize that 7 plus 7 is 14 and 7 times 7 is 49, we can go straight to this step. We can go straight to x minus 7 quantity squared equals 0. Okay? X minus 7 equals 0. Yeah. And we can do this here. We can square both sides, or square root both sides. X minus 7 equals 0, and x equals 7. Right? And there we go. All right, so again, the old method still works. So if you prefer the old method, feel free to use it, but the lesson's going to talk about something called a perfect square. Okay. Last one. X squared minus 25. They're going to talk about a pattern called the difference of squares. But really, we can solve this simply by undoing. There's only a single x, right? So we can add 25 to both sides. Add 25 to both sides. And we get x squared equals 25. And then we can square root both sides. But remember, when you square root, there are two solutions, positive or negative. And this is why. Negative 5 times negative 5 is positive 25. And positive 5 times positive 5 is also 25. So if I'm solving x squared equals 25, x can be negative 5 or positive 5. So the positive or negative. So a good rule to remember is when you square root both sides of the equation, you get a positive root and a negative root. So negative 5 or positive 5, or you can write it as plus or minus 5. You can write it both ways. Okay. All right. Now the way they'll show you, let me back up here a little bit, is using a difference of squares pattern here. And we recognize this is a difference of squares because x is squared and 25 is 5 squared. So you can think of this as x squared minus 5 squared. And when you have a difference of squares, you can write it like this: x plus 5, x minus 5. And again, either x plus 5 equals 0, or x minus 5 equals 0, or x equals negative 5 if I subtract 5 from both sides, or x equals positive 5 if I add 5 to both sides. Same solution, slightly different way to think about it or write it, but both methods work just fine. All right, that I think is it. Let me know if you need any help.